Hello and welcome to the next episode of Self-Healing Infrastructure. Yesterday we were in Container Days and we presented in front of around, I think 200 people it was, our current status of self-healing infrastructure. Unfortunately, we had Wi-Fi problems, so because of the Wi-Fi problems, we could not show all of the things, especially, and this was very unfortunately, the very complex case we could not show you guys. So I decided to make a very quick YouTube video. Okay, before we jumping to the full complex case about self-healing infrastructure for the guys which maybe watched this video or didn't watch the previous one, we have a smart CLI tool which is called GPT script, or you can also use Homes. And it helps you to do things, and you can just install it on the local machine. It knows all the tools which are running on your local machine. And it's very, very useful. And I would just show you a very simple example, then you will understand what you can do with that. So I've installed it on my local machine, and I say GPT, GPT is my alias, gather all Docker image names from the current Kubernetes cluster. I press enter. It connects to our private ALM. It translates that to commands, so basically these commands here. And then it executes it on my current Kubernetes cluster, which I'm working on. So it has this kind of Docker images currently running. And this is really cool because I don't know this command by heart, and so it makes it way much easier to use it. So I don't need to go to ChatGPT, say this one, copy and paste this one, paste it here inside. Maybe it's wrong. So sometimes when it's the wrong command, he will fix it on itself. So this is really cool. And we had, with this GPT tool, with the GPT script, we will put this one into a Kubernetes container, so basically inside the pod, and we'll run it then. So how does it look like? So this is a more complex case. So we have the CLI tool and we give it multiple commands. So this on the right side, you see the full architecture. So you have the shared context, which describes the context, which should be shared between the agents or the execution tools. Then you have here a cron job or a job, which will be running. And then you have the DevOps bot agent itself. It collects, for example, alerts, then pushes this alerts to Slack, reacts based on this alerts, then finds some issues and pushes them. So in a very simple manner to explain that is 6 steps. We need 6 steps for a complex case. So the first one is scan the cluster for issues. So it scans pods, security, services, and all the things. Then it alerts to Slack that there is currently an issue and that you will try to solve it. The third one is that inside the pods it sets up gates and sets all the things. Then you should check out the source code. So because we like GitOps, so where currently the Kubernetes cluster is defined, or the Kubernetes infrastructure components are defined. So please check out the code. Then analyze the problems and fix it. So take a look at all the YAML files, analyze that, and then fix the issue. And the last point is push this one to a specific branch where then a pull request can be done. And this one should be all fully automated. Search inside the Kubernetes cluster CCE if you find some issues. The Kubernetes cluster is hosted on Open Telecom Cloud. This is important information, so you know which kind of Kubernetes cluster is there, because there's specific annotations and all these things. Report the issue, so read the TXT file, so everything what he's found, and post it to Slack webhook URL. So when we will execute this one now, so we will open here this one, and I'll delete the old deployment. It's not there anymore. So we say helm -f GPT scrub values secret, because in the value secret YAML are my credentials. GPT script bot, and we need for sure install. That would be very important. So when we install this one, what do we expect? So inside our Kubernetes cluster, we have a faulty service. Keep control, get this for C-A. And you can see here, this one has the wrong annotation. And that's why the current external IP is pending. And this one you should find on its own. I deployed also multiple more stuff, so not to make it super easy, so you have a little bit more things. So there's Kafka running, Prometheus stack is running, Kivano is running, and Argo City is also running, to have a little bit more workload, so that does not look like Hello World. and has more Ingress Kubernetes resources deployed. Okay, so then what should be done is then here we have this open source project. You can see here that has currently just one branch, and yeah, inside Slack here should be a notification. Let's just install it and let's see what comes. So we installed this one, and let's take a look at the logs. Kube control reports. Kube control logs fix my cluster, and you see it goes through every of the components, because I just said to him here, search inside the Kubernetes cluster, you find some issues. Search for pods, deployment, stateful set, PVC, PV, and service separately. For example, if you take Prometheus, if you don't write the own rule, it will just ignore the current issue which we have there. And this one can find it on its own. You can see here, it found it already. So I have identified the issue with the service wrong load balancer annotation namespace. The service, my load balancer service, has a pending external IP, which indicates a missing annotation. This needs to be addressed. Amazing, right? Cool. So yeah, now if everything works perfectly, it should also get a notification. So this is this part here. And you see here, we got the push message. It says to us we need to set the ELB ID to resolve the external IP issue. So what do we want to achieve? We don't want a fully automated infrastructure. It's also not compliant with our company rules, and also we need the 4 I's principle. So fully automated, it will never be. So what we want to achieve is to automate these things, to amplify us as a software developers or as a DevOps consultant or platform engineers. So what it should do is to give us hints where we should take a look at, automate some of our workloads, give us new ideas how to solve the issues. Especially juniors will be having trouble to detect this kind of issues. One day before I made my conference speech on the Container Days, I had exactly customers exactly this problem, and he didn't knew the solution. So he's already finished. Let's take a look. So there's currently one branch, and if everything worked perfectly now, we should have 2 branches. So there's 2 branches now. Let's take a look what he finds out. Don't be surprised, it's not a 100% solution, because this is already a complex case. Okay, then let's compare this one. So we go here, right click, Git, compare with branch, origin, AI ops. Okay, the formatting looks not properly done, but we're working with the LLM. But the most important thing is, you can see here he changed the LB ID already. And as I said, we are on the road, so we're improving this one, but he replaced this one properly, and so therefore he set the right annotation, which is already really cool. He reported already what we need to change. He created the branch for us, so we just need to work a little bit more on the formatting. And how to change this formatting so the results will be better, I will show in the next result. Because with Confluence and with the RAG system, with the IETS AI, I can exactly show how to solve this kind of issue with the formatting and to create way much better results, in a very, very fast way. So basically just I need to write some sentences and then the results will be way much better. So stay tuned for next time. See you. Bye bye.